Welcome back. So in our last video, we determined that a good way to select a sample that accurately reflects a population is to select that sample randomly. Okay, that only gets us so far. At least we know that humans shouldn't be in charge of determining who's in the sample, and by randomizing, an individual or a type of individual that is fairly rare in the population will naturally be rare if it's sampled at random as well. An individual that's fairly common will be fairly common if you sample randomly. But it turns out there are several different ways of doing random sampling, and different methods are better depending on the nature of your population and what it is you want to study. So in this video, we're going to look at 5 different methods of random sampling that you can choose from to select a sample that accurately reflects the population. So let's deal with this sample first. Well, let's suppose there are 2,000 students enrolled at Anderson High School. It's maybe a little lower than that, but it's an easy number to work with. And let's say you want to estimate the average GPA of all students in the school. That's something that I think would be interesting to know. And I'm fairly confident at this exact point in time, there's not a soul on earth that knows that. What is the average GPA of all students at Anderson High School? I don't think anyone's even bothered to calculate it. So, interesting. How could you randomly select a sample to accurately estimate this parameter? Obviously, the true average GPA of all the students in the school is unknown. No one knows what it is. And it would be very difficult to get that information. At least for you. Probably for me too. I don't even think I can do it. But the best way we could estimate this, since we can't know the truth, is instead of asking everyone or getting data on everyone, we'll just take a sample. The more our sample reflects the population, the more accurate our estimate of that parameter will be. So, how can we randomly sample the population to get a good estimate? Well, the first way that we're going to talk about is called simple random sampling. And I will typically refer to simple random sampling by its acronym, SRS. So this is probably the most basic or simple method of random sampling. Yes, we statisticians are very clever with our naming conventions here. It's simple random sampling because it's the simplest way to randomly sample. And you essentially already know how to do it, based on what we've talked about before. So, in a simple random sample, it's important to know this is a characteristic of an SRS. In a simple random sample, every sample of a given size, no matter what n is, every sample of that size has the same chance of being selected. And you may think that's obvious if we're sampling at random that that's the case no matter what. This is actually the only method of random sampling we're going to talk about today where this is true. By default. Every single time. This is actually a stronger statement than saying every individual has the same chance of being selected. I'm not going to take the time to parse the difference between those two things, but it is also true that every individual in the population has the same chance of being selected also. Okay, so in order to perform simple random sampling or any of the other methods we're going to talk about, you need to know how many individuals you want to sample. And that depends on a lot of things. One of them is probably the population. So if the population is 2,000, we probably don't want to sample all 2,000. If we could, why would we even bother taking a sample? So we want it to be relatively easy to actually take this sample. So it can't be too high, but we want an accurate estimate of the average GPA, so we can't take too small of a sample either, or it might not be that accurate. What's the best sample size to take? Well, that's a question for later in the course. For now, we're just going to say we're going to take a sample of size 200. So again, this is a determination that you're going to need to make no matter what the type of sampling. So how are we going to ensure that every sample of size 200 has the same chance of being selected and make sure that the sample is selected randomly? Well, this is not a very complicated process. This is still in SRS. The first step is to number all the individuals in the population. So in our example here, we're going to be numbering all the students from 1 to 2,000. Once we have all of our individuals numbered, then we just need to use some kind of random number generator to choose this many random values in this range. Right, so we need to use some kind of RNG, a random number generator, to select the first, however big your sample size is, that many unique numbers in the range that you've created. So in our example here, we want to select 200 unique values between 1 and 2,000 to represent the students in the sample. The reason that we need unique numbers in the range, if we sample the same number multiple times, then remember, each number represents a student. So if we sample the number 493 twice, then we'll be sampling the same student twice. Is that what we want? No. Why? Because at that point, we're not really estimating the average GPA of all students in the school. We would only want to look at each individual once. If that individual were to have a really high or really low GPA, that could bias our sample in that direction. If we can avoid those sources of bias, we will, and by sampling unique numbers, we can do that. One problem with a lot of random number generators is that they give you repeated values sometimes. So you have to, if you're explaining how to create an SRS for a given situation, you have to make sure that you either say repeats are going to be thrown out or that we're looking at unique numbers. It's super important. So, just from these two steps, we can guarantee that every possible sample of size 200 students has the same chance of being selected. There's no bias, there's no favoritism, no one's more or less likely to get selected. Everyone has the same shot. That's an SRS. Pretty simple, right? Okay. That's right, Kat. It's easy. I want to make a distinction here between the terms sampling with replacement versus sampling without replacement. These are two different ways. You can take an SRS either way, and I've touched on this a little bit already. We said we wanted unique numbers. So either we're not going to allow repeat values to be selected, or if they come up, we're going to throw them out. That is sampling without replacement. Sampling without replacement. Right. Yes. I always have to think a little bit about it. Sampling without replacement means essentially repeats are not going to be allowed. Okay, you're not going to be able to replace a student into the pool once they're already in the sample. Repeats not allowed. Repeat values not allowed. Okay, sampling without replacement. We don't want those repeat values. Now, there are some instances in some scenarios where you would want repeats. I'm remembering an example from my one semester class where we first are learning how random number tables work, and you're trying to figure out how likely it is that multiple people have the same birthday. The individuals in that example are the dates of the year, and by using the random number table or a random number generator, you can determine if the same number comes up multiple times, that represents two people having the same birthday. And that's actually the whole point of the sample, is to determine if that's the case. So if you sample without replacement there, you'll never get two people with the same birthday, even though two people can have the same birthday. So in some instances, you will want to sample with replacement, which means if there is a value that you sample, you will replace it back into the pool so it can possibly be sampled again. Okay. So you can't just say one way or the other, oh yes, for SRS you're always going to want to sample without replacement. You'll have to take a good look at the situation that you've got, who or what is making up your population, how are you determining the sample, and that should tell you whether repeat values are okay or not. Another thing that's important to know here, in order to create a simple random sample and actually carry it out, you need to have a list of all of the individuals in your population. If you don't, it's going to be very hard to do step number 1. So you actually need to have what's called a sampling frame. The sampling frame is the name for the list of all individuals in the population. That might seem obvious, like, well, yeah, I would want to know everyone in the population before I take a sample from it. But for those of you that took a sample in person in the one semester prop stats class a year or two back, it's not so easy to always have a sampling frame. If you want to take a sample of all the students in all of your classes, for instance, you wouldn't be able to take an SRS unless you had a list of all the students in all of your classes. You would have to get that from each of your teachers separately. It's actually not that easy to get the sampling frame, and the bigger your population is, the harder it is to obtain this, right? Do you know of a way you could get a list of all the students enrolled at Anderson High School? I don't think that'd be very easy. Again, for you or me, because enrollment changes all the time. By the time someone printed out a list for you, it might already be out of date. And that's if they would even give the list to you. I don't even know if they'd be allowed to do that. So in some cases, this isn't a given. And if you don't have a sampling frame, you can't take a simple random sample. That's just the way it is. So it won't always work out to do it this way. But there are other ways of sampling. And the second way that we're going to talk about actually also requires that you have this. But it's slightly different. So I actually want to erase this and start with a new board, because the next two sampling methods we're going to talk about are, well, I want to compare them directly. Okay, so we still want to sample 2,000 or 200 of the 2,000 students at Anderson High School and find their average GPA. We've learned about simple random sampling and how that works. And there is another way, well, there are several, but here's the next one. It's called stratified sampling. Now, I want to go back to SRS. Is it possible with simple random sampling, we're sampling 200 students, is it possible we could get a sample of 100 freshmen and 100 sophomores? It is, actually. It's not particularly likely, but it could happen. In fact, it's possible to get 400 freshmen. Or not 400, 200. It's possible for all 200 students in our sample to be freshmen using an SRS. Every sample of size 200 has the same chance of being selected. 200 freshmen, it could happen. Is that what we want here? Is that going to give us an accurate estimate of the average GPA of all students if all the students in the sample are freshmen or sophomores? No. So maybe the best way to estimate this parameter is not with an SRS. Maybe we want to ensure that we've got some students in each of the 4 classes. This is where stratified sampling comes in. In this method, you are going to divide the population into groups. In stratified sampling, the groups are called strata. We're going to divide the population into groups. So in our example here, the population is all the students at Anderson High School. And we're going to divide that population into groups. And in this case, since I want to estimate this variable in particular, GPA, and I think that GPA is different by class. So freshmen have an average GPA, sophomores have theirs, juniors have theirs, seniors have theirs. I think they're different across the classes for several reasons, one of which being the higher up you go, the more opportunity you have to take weighted courses, dual credit, AP, all that stuff. Freshmen don't have that opportunity, so maybe their GPAs are going to be lower on average than a juniors or a seniors. You can make an argument that juniors and seniors GPAs could be lower because they have more classes they can fail. It depends, right? But I have reason to believe that if we divide the student body by class, that this is going to be different, so therefore I want to make sure my random sample includes some from each class. So, if you believe your population is composed of heterogeneous groups, and heterogeneous meaning they're different from each other with respect to the variable you're looking at. If you believe that your population can be broken up into groups that are different with respect to your variable, stratifying could be worthwhile. We don't just want to take an SRS and get a whole bunch of freshmen and sophomores. We want to make sure we get some students from each in our sample. So we're going to divide this up into freshmen, sophomores, juniors, and seniors. So in our example, there are 4 groups or 4 strata. Depending on the situation, you could have 10 strata, you could have 1,000 strata, you could have 2. It depends. Okay, here we have 4. And we want to make sure we get a sample from each group. And how many you take from each group is entirely up to you. We know we want to take 200 total. We've got 4 groups. And it might be wise to sample proportionally to how many students are in each of these classes. For the sake of this example, I'll assume there are about 500 students in each of the 4 classes. So we're going to sample 50 from each group. Okay. So we want to take a sample of 50 freshmen randomly. How? A simple random sample. We're going to take an SRS of 50 freshmen. We're going to take an SRS of 50 sophomores, an SRS of 50 juniors, and an SRS of 50 seniors. I'm sorry I made that a square. I'll fix it. I changed my mind as I went. This just makes a really ugly circle. It's an oval. Sorry. Okay. So this is how stratified sampling works. Instead of just taking a sample from the population as a whole, we're splitting the population into groups, and we're taking a simple random sample from each group. That is how stratified sampling works. Now, why am I making such a big deal about it and writing in caps, yelling at you? Because stratified sampling usually gets confused with the method we're about to talk about, and I want to differentiate them as much as possible. In the next one we're going to talk about, you don't take an SRS from each group. So I want that to go in your notes. I want you to write it in caps. I want you to bracket it off, maybe underline or highlight excessively, whatever you need to do. This is the defining characteristic for stratified sampling. And it's best if your variable of interest is different between those groups. Otherwise, you should just SRS from the population. I want to note before we get to method 3, you still need the sampling frame to do this, right? You may not need a list of all the students in the high school, but you would at least need a list of all the freshmen, so you could take an SRS of 50, a list of all the sophomores, all the juniors, and all the seniors. You can't do a stratified sample if you don't have that sampling frame. Okay? So, the next sampling method we're going to talk about cluster sampling really comes into play if you don't have that sampling frame. Let's say you have no idea who all the students at Anderson High School are. You can't do an SRS. You can't do stratified sampling because you need a list. So for cluster sampling, well, if you don't have a list of everyone, you at least know that, well, at least during 4th period, all the students at Anderson High School are in the building. How are the students organized when they're in the building at any given time? Well, in 4th period, a good chunk of them are in the cafeteria, but they're in classrooms, right? Cluster sampling allows you to sample randomly without the sampling frame by sampling geographically. We're still going to split the population into groups, but we're going to split the population into groups that form naturally. And usually cluster sampling, the population is broken up into groups by location. And so in our example here, we're going to use classrooms. So instead of breaking the population into freshmen, sophomores, juniors, and seniors, we are going to break the population into classrooms. How many classrooms are in Anderson High School? Oh, God, I have no idea. Is it like 100 maybe? Just a rough estimate. I'm not going to draw 100 classrooms here. You'll get the idea. I'm trying to make this diagram easy to read, so I've made it just 9. You can imagine there are dozens more of these popping out of here. This kind of looks like a coronavirus. I apologize. Okay, so we've broken our population, all students at the school, into what classroom they're in during, let's say, 2nd period. So we'll include the Career Center, D26. Okay. Are we going to be taking a simple random sample from each classroom? No. We would need a list of all the students in each classroom to do that. Plus, that would make it stratified sampling. What makes cluster sampling different? We're not going to take a simple random sample from each classroom here. Instead, we're going to sample classrooms. So, take an SRS. Of groups. And the groups in cluster sampling are typically called clusters. Okay? But here we're going to take an SRS of the groups, of the classrooms. This allows us to sample without having the sampling frame because we can physically just go to a classroom and look at the students in there. So we're going to take a random sample of the classrooms. So let's do that and say 3rd one, the 4th one, and the 7th one. Okay? And we would sample as many classrooms as we needed to get to 200 students, which is what we wanted originally. Okay? So classroom 3 is in our cluster sample. Now what? Well, we're going to sample every individual in this group. Every individual in the group. Okay? So if one of the classrooms, one of the groups is in our SRS of groups, we're going to sample every individual inside. So we're going to get all the students from this room, all the students from that room, and all the students from that room, and all the other ones that aren't pictured here. Okay? And we'll do that until we get to 200. We don't need a sampling frame to do it this way. And this is easier to get if you're thinking about doing it practically, right? If you take your sample this way, you might have to go to every classroom in the school. That's not easy. That's going to take a while. Okay? Doing it this way, you only have to go to a certain number of rooms. That can be easier. And depending on how big your population is, this might be even better than this. Even more so than it is here. Okay? Think of a sample being the entire United States. Do you really want to do a stratified sample where you got to go all over the country? Or would you rather break the population of the United States into groups geographically so you only have to go to a certain number of places? Seems a little better. Definitely seems easier. It's not necessarily a good idea, though, to do it this way if your classrooms are different with respect to your variable. What might happen for this example if one of the classrooms in my SRS is my AP Stats class? Is my AP Stats class representative of all the students in the school? I'll just go ahead and answer for you. Not even close. And that could inflate our estimate of that parameter. But the hope is that by sampling randomly throughout the school, maybe I get some high classrooms, but I might also get a remedial class or two. Okay, it's not perfect if these classrooms aren't homogeneous. So cluster sampling works best if the groups are homogeneous or similar with respect to your variable of interest. Okay. So what I'm trying to say here is, in this particular example, cluster sampling might not be great either, because you do have that opportunity of getting classrooms that could seriously pull your GPA up or down to an exaggerated degree. It'd be best if all the classrooms in the school were populated by students at any given time who were similar in terms of GPA. Since they're not, this might not work very well either. So let's say we don't have our sampling frame, we don't have a list of all the students in the school, and we also don't necessarily want to do cluster sampling because we're afraid that we're going to get classrooms that will bias our sample. There is still another option for us. Systematic sampling. What's nice about systematic sampling, not only do we not need the sampling frame, we don't even necessarily need to know how big the population is. It doesn't even matter. So if there aren't exactly 2,000 students enrolled, which I'm pretty sure there aren't, it doesn't even matter. It's really nice. How does systematic sampling work? Well, every student that goes to Anderson High School enters the building through either the north or south doors every morning, right? They might then go to one of the D26 shuttles, but let's say we can catch every single student coming into school through either the north or south entrance. We can have people standing at the entrance at both of those entrances. And I'm not saying this is workable. I'm not saying you would actually do this because it probably wouldn't work out very well. But we could sample every 10th person that walks through the door at each of those entrances. And by the time that we were done and all the students had filed in, we would have a good number of responses. Right? So it's not random in the sense that it's every 10th person, but there's no reason to suggest that every 10th person that walks through the door has something in common regarding their GPA. So it's effectively random, right? It's not like students come into the school based on their GPA or their class rank. Can you imagine if first thing in the morning, like, It's like when you're boarding an airplane, like, will the valedictorian please enter the building first? The valedictorian. And everyone else has to wait until the valedictorian like goes in. Like, that would be stupid, right? So we could sample that way. And it would probably reflect the population accurately. Taking every 10th person, we'll get some people that get there really early. We'll also get some of the people who get there late. And a lot of people in the middle. Right? So this might actually be the best way to get this sample. So systematic sampling is when you take, or when you sample every kth individual. I say k, it could be a number. So in the example I just proposed, k is 10. You could take every 10th individual. You could take every 4th individual. You could take every 1,000th individual if your population is very large. And you could do this physically, like as students enter the building, or if you did have a sampling frame, if we had a list of all the students in the school, you could still do systematic sampling by taking every 10th person in alphabetical order on the list. That could work. And what wouldn't work is if you had a list organized by GPA and did this. That would not be a good idea. First of all, you wouldn't need to take a sample, would you? You would just collect the data. Okay. But systematic sampling is great if you don't have a frame, and if your population is easily sampled because they're like all in the same place, or you do have that list. You sample every kth individual, starting at a random value between 1 and k. So if I wanted to sample every 10th student, I would use a random number generator to give me a random number between 1 and 10. Say it gave me 6. I would sample the 6th, 16th, 26th, 36th, and so on. Every 10th student that walked by me. Okay. It's a totally legitimate way of random sampling. Totally legit. It's best if none of the other options are workable. Okay. I said there were 5 methods of sampling. I've listed 4 here. The 5th is multi-stage sampling. And as the name suggests, multi meaning more than one, it's when you combine more than one of these methods together, or if you like stratify in 2 ways at the same time, or something like that. So it's a combination of these techniques. Combination of multiple techniques, multiple methods. Or you can use the same method more than once. If you ever want to like go to sleep or something, I can record myself talking about what I did at the Census Bureau. The survey I worked on was a multi-stage sample. We stratified on many variables all at the same time. Way more than just one. It was at least like 5 or 6. So the sample I worked on, it was very complex. The population was all US businesses. And that is a very large population, so you need to stratify on several different variables at the same time to get a reasonable sample. And that's how that worked. I've got more details, but I want you to stay awake. So we'll just leave that there. So in this video, which, man, it's always longer than I want it to be, you've learned 5 different ways of taking samples randomly. You could take a simple random sample if you've got the frame of all the individuals in the population and you don't care who's in it or who's not, because everyone has the same chance of being selected. You can get some weird samples that way, though. You could take a stratified sample if your population is broken up into groups somehow where those groups are different with respect to your variable. If you don't have a frame, or if these groups don't exist, you could do a cluster sample, which is easier to obtain is usually separated by location, geographically, and the difference between these two is when the simple random sampling happens. For stratified, you take a simple random sample from each group. Cluster, you take a simple random sample of the groups. And if a group is in that simple random sample, you take them all. Every individual within the group. If none of those are very good, you can just do a systematic sample, every kth individual. And multi-stage sampling also exists. It's usually not covered on any test, so I just threw it in there because it exists. So, a long video. I apologize. We're going to try and get through this unit before fall break. That's my goal, so the videos might be a little longer. But now that you're in school at least a couple days a week, maybe it's a little easier to get everything on track, get on schedule. And if you're watching this in class, hi! The bell should ring soon. So we will see you in the next video. Have a great day.